Hello, welcome. Let's try to solve another Leetcode problem 2931, maximum spending after buying items. So the problem is that we are having some values array. So this values array is going to be a 2D array. So let me just explain it maybe. So it means for the row, each of the row, it means each index of the row, it means for the ith shop. And each column, it means this item. We just want to buy any one of the items in the values array. Maybe let me just use this way to explain it. So we are giving a 2D array. So this is going to be the 2D array. And we can turn this 2D array to a 1D array, it doesn't matter. But the meaning of the 2D array, it is just the ith shop. So for example, for the zeroth shop, this shop we have some items. So we have the zeroth item, one's item, and second item. It's just like that. So for the first, so 0 it means the first shop, 1 means the second shop, and this 2 index it means the third shop. And also for the items, so the 0 means the first item, 1 means the second item, and index 2 means the third item. So what are we going to do? We are going to buy all the items, and we should not repeat. So for example, if we buy this item 3, we cannot buy it anymore. But for us, we can buy all the items, and we want to calculate the maximum value we can get. But for the first day, for example, we're going to choose an item maybe 1. So it is day 1, so 1 times 1. And for day 2, and we're going to choose another item maybe this 2, and it's going to be 2 times 2. And for the last day, maybe it is 9 times 9. So if you take the examples, the example 1 or example 2, maybe you can find some patterns, and maybe you can solve the problem. Because definitely according to the examples, so for the first day, we always try to choose the smallest value. And the second day, because this is chosen, and then what left behind is that we're going to choose the smallest value, so it's going to be 2. So for the last day, definitely it's going to be the biggest value. And then we're going to sum up all those values, and we get the final result. It's going to be 285. Actually, your guess is right, and this is the right answer. But is there some formula about this kind of problem? Actually, there is a formula. It is called inequality formula. So the inequality formula means for an array, if it is sorted like A1 is less than equal to A2 and less than equal to A3 and less than equal to AN. So we have one formula. So another formula is similar. It is just a different value. It is B1 less than equal to B2 and less than equal to something and less than and equal to Bn. So if we have such kind of two formulas, so the formula 1 and formula 2, so the final result is going to be the A1 times B1. I'm sorry, it is B1. So it is AI BI from I equals to 1 to n. So this is going to be the maximum value. So it is AI BI. So my writing is not so good, but definitely let me write it better maybe. So the AI BI, so this is the AI and BI, from 0 to n, from 1 to n. So from 1 to n, it's going to be so I equal to 1 to n. So this is going to be the maximum value. So this kind of a value is going to be more than all other values. So if it is not sorted, maybe it is bigger than A1 times Bn plus A2 times Bn minus 1. So this kind of formula A1 Bn plus something A2 Bn minus 1 and until something, and this is gonna be the smallest value, but we are going to calculate the maximum value. So basically we can use the a1 times b1 plus a2 times b2 until an times bn. So this is going to be the final result. Now let's just use this kind of idea to solve the problem. So we're going to check all the values. Let's just prepare our PQ, priority queue, because we need to find the smallest value for each of the time. So we can choose the val array inside values, and for v inside this val array, and we're gonna put it inside the priority queue. And now we're gonna record the final result. We're gonna prepare a counter and we're gonna prepare a result. So the count gonna starting from 1 and result gonna be 0. So we're gonna check the PQ. So while there's something inside the heap, and we're gonna take the minimum value, it's gonna be this n, and we're gonna pop it out, and we're gonna add it to the final result. So it's gonna be this count from the beginning. It is 1. It means day 1. Maybe let's just use a day. Yeah. So it's gonna be this day times this number n, and then we're gonna update the day to the next day until we get the final result. So we just need to return the final result. Now let me just run it. Yeah, let's just put PQ inside to make it right. Yeah. Now as you can see it works. Now let me submit it to prove it works. Yeah, as you can see it works and it's pretty fast. So I don't think that is the reading is really high. Actually, it should not be so high. Maybe somebody didn't know about the formula. Actually, this is just a formula. According to the formula, we should know this is gonna be a greedy problem. So for the greedy problem, we're gonna use a min heap and to find the final answer. Actually, the coding is much easier, as you can see from it. I think that's all for it. And for this problem, the time complexity is m times n log m times n. So this is m10, n is 10 to the power of 4. So it's gonna be a small value. That is why it's so fast. Thank you for watching. See you next time.